Here is another compound we are about to name. So the rules of naming remains the same. So the first thing we do is we look for the longest chain and look for the name of the parent chain. So as it stands now, we have one, two, three, four, five. Five carbon. Five carbon should be pent. Okay? Should be pent or pent in the Roman numeral stands for five. Then now we have branches, we have substituent. This is a branch because it's carrying carbon, but this is not carrying carbon, so it becomes a substituent. So we have one, two, and two branches. Now, the next thing is what is the name of the longest chain? What is the root name? Under nomenclature, we have another term called functional group. Huh? The functional group. So OH belongs is used to identify a certain homologous series, which are alkanols. And we also have another functional group, which is this part. When condensed, we have COOH. This functional group identifies another family of organic compound, which is alkanoic acid. So, what happens if we have two functional groups just on one hydrocarbon? We have to give this name. You have to look for the one that has more priority. So, when you encounter COOH and OH, this carboxyl or alkanoic acid group with this functional group COOH has higher priority than this, so it will not take the root name. So since we are having 1, 2, 3, 4, 5, the root name for this will be pentanoic acid. So that is the first thing you do. You know the root name or the main name. So every other thing here becomes either a branch or a substituent. The OH is supposed to have a functional group of alkanol. If there was no COOH, becomes a substituent. So we'll call it hydroxyl. So now we'll number our carbon atoms. For this case, the numbers must start from the one bearing the functional group. Okay? And even if we are to go from this side, this first branch is on carbon number 2. That's 1, 2. But here, the carbon that is part of the functional group is now going to be our number 1. So no need to look for where to start numbering. So this is 1, 2, 3, 4, 5. So if that's the case, we'll now start numbering the substituents and branch alphabetically. This is methyl. This is hydroxyl. This is bromine. So by the initials of their name, bromine comes first. Okay, hydroxyl is H. Then this is methyl. So B comes before H before M. So we'll start from bromine. So now let's get the names out now. 1, 2, bromine is on carbon number 2. So we have 2 bromo, comma. Between hydroxyl and methyl, hydroxyl comes first. So an hydroxyl, OH is on carbon number 3. Then we have 3 hydroxyl. Now we have 2 branches. One methyl is here, another methyl is here. So we have to name them. So this methyl is on carbon number 3. The other methyl is on carbon number 4. So we indicate the positions by the numbers. So next thing that follows is 3, 4. That's 3, 4. Since there are 2 methyl, use the prefix that says di. Since there are 2, so it will now be dimethyl. Then the root name now follows, which is a pentanoic acid. So the name for this compound now is 2-bromo, 3-hydroxyl, 3,4-dimethyl pentanoic acid.